Description of the topic. Items description of the topic course data analysis for social science teachers topic what is data? Types of measurement module ID 1.2. 1. What is measurement? Measurement refers to attaching numbers or labels to objects or events. We know how to measure heights and weights of individuals. We measure height in, say, centimeters and weight in kilograms. The following table contains statistical data of weights for a class of 60 students. Individual height, CMAs, 170 to 168, 3 172. 60 176. This table presents the data relating to the heights of a finance class of 30 students. Individual weight, kg, 175 to 71 382. 3078. Through measurement, we can generate data. Data is a collection of measurements. Data is analyzed to yield some insights. We may describe the central tendency of the heights and weight data using mean, median and mode. We can also describe the variability in the data using range, mean deviation, quartile deviation and standard deviation. We may also use such tools as skewness and kurtosis too. PAGE to vertical bar 8. Describe the shape of the distribution. However, the choice of a particular measure of central tendency depends on the way we measure the data. Similarly, when we are trying to describe the relationship between two variables, the choice of the statistical technique depends on the way the two variables have been measured. Can we measure anything easily? When we try to measure something, we realize that it is far easier to measure certain things compared to the other. Taking physical measurements like height, weight, blood pressure, and blood sugar is much easier than measuring the constructs such as attitude, motivation, honesty, and punctuality. Just as we use a measurement tape to measure height and a weighing machine to measure the weight, we need some instrument, popularly known as scale, to measure the constructs such as attitude, motivation, honesty, etc. Before we understand how a scale is developed to measure constructs like attitude, motivation, honesty, etc., let us devote some time to understand different levels at which something can be measured. Different ways, levels, of measuring a construct. We can measure a particular thing in different ways or at different levels. Let us say we are trying to measure the age of our respondents in a survey. We may measure the age in the following ways or levels. A. We may just categorize the respondents into three groups: young, middle age, and old age. B. We may categorize the respondents into certain age intervals: below 30, 31 to 60, 61 to 90, 91 and above, and C. we might also record everyone's age in the completed years, completed months, completed days, etc. 2 levels of measurement. Broadly, there are 4 levels or scales of measurement: nominal, ordinal, interval and ratio. Before we proceed to understand different levels or scales of measurement, let us re-emphasize. The choice of statistical tools to analyze the data is primarily dependent on the way the underlying construct variables were measured. PAGE 3 vertical bar 8. 2.1 nominal scale. When we measure something using a nominal scale, we use numbers as just labels or identifiers. For example, each player in a cricket team is labeled with a number printed on their jersey to easily identify them when they are playing. These numbers are just labels and do not make any difference even when we interchange the numbers given to two players. Further, we may not assign consecutive numbers to players. Even when they are assigned consecutive numbers, say 1 to 11, the order will not have any meaning. I used to watch Indian cricket from 2001 to 2010. I remember Rahul Dravid wearing a jersey numbered 5 and Sachin Tendulkar wearing a jersey numbered 10. Did these numbers have any significance? Can it be said that Tendulkar was twice efficient as Dravid? For that matter, Ganguly used to wear a jersey numbered 1. Can it be said that Tendulkar was 10 times better than Ganguly? Further, we can also assign alphabets like A, B, C, D instead of 1, 2, 3, 4. It too does the same purpose. Now we realize that when we are measuring something using a nominal scale, we are just assigning labels, or we are categorizing the subjects into predefined bins. Let us take another example. A market research firm wanted to do a survey of brand loyalty. Let us say this survey in 3 cities, namely Hyderabad, Delhi, and Mumbai, and we are interested in the city of origin of our respondents. When we try to measure the city of or origin of respondents, we simply pick a respondent, note him/her and put him/her in one of the bins of Hyderabad, Delhi, and Mumbai. Gender, color preference, nationality, personality type, native state are some of the examples of variables that are generally measured on a nominal scale. Now let us turn to the ordinal scale. 2.2 Ordinal scale. When we measure something using an ordinal scale, again we attach labels to the object's respondents. However, here the labels can be arranged in an order. Consider the example of the designations of teachers in a university: assistant professors, associate professors, and professors. These are just labels. While we pick a teacher, we will be able to categorize him/her into one of the 3 bins. However, these labels have some order. When organized from the lowest to the highest, we will get the order starting with assistant professor, associate professor, and then professor. Similarly, the designations in police or military organizations are on an ordinal scale. These designations have some order. Sometimes we also assign numbers as labels. Think of ranks of students in the NET examination. The label first rank is assigned to the student who has scored the highest marks, the next highest scorer gets the label second rank and the next, the third rank and so on. PAGE 4 vertical bar 8. The ordinal scale measurement is one step better than the nominal scale measurement in that the labels assigned can be arranged in an order. However, we notice that the distance between two consecutive labels may not be the same. Let us get back to the example of the NET examination. The differences between first rank holder and the second rank holder may not be the same, and the same is true between the second rank holder and 3rd rank holder. Let us say the first three rankers have scored the 98, 96 and 92 respectively. The distance between first and second ranker is 2 marks, whereas the distance between second rank and third rank holder is 4 marks. Individual rank marks A1 98, B2 96, C3 92. 2.3 Interval scale. An ordinal scale wherein the interval between any two consecutive data points is the same can be termed as an interval scale. That means in an interval scale, the data points are ordered and the distance between any two consecutive data points is the same. The popular example of interval scale is temperature. We know the difference between 10 degrees Celsius and 11 degrees Celsius is same as 18 degrees Celsius and 19 degrees Celsius. Similarly, the difference between any two consecutive points on a Fahrenheit scale is also the same. The intervals are same. However, we cannot say 20 degrees Celsius is twice as much as 10 degrees Celsius. This is not possible because we do not have any absolute zero on a Celsius scale. The Celsius scale was developed noting the freezing point of water as 0 degrees Celsius and boiling point of water as 100 degrees Celsius and dividing the distance into 100 equal parts. That's why the Celsius scale was originally called the centigrade scale, that is cent means 100. On the contrary, on a Fahrenheit scale, the distance between the freezing point of water and boiling point of water is divided into 180 equal parts. The freezing point on Fahrenheit scale is noted as 32 degrees Fahrenheit and the boiling point is 212 degrees Fahrenheit. The distance is divided into 180 equal parts. 212 minus 32 equals 180. However, on both the scales, the zero is arbitrary. In fact, the original centigrade scale has 0 as the boiling point and 100 as the freezing point. That means it is running in the opposite direction. 100 degrees Celsius then would have meant very cool. As there is no absolute zero, the ratios of numbers on an interval scale are not meaningful. That's the reason why we can say that 20 degrees Celsius is not twice as 10 degrees Celsius. Now, let us examine in detail why the ratios are not meaningful on an interval scale. PAGE 5 vertical bar 8. We know the equation to convert Celsius to Fahrenheit. I.EF is equal to 32 plus 1.8C. Let us look at the following data on two scales. Celsius scale, Fahrenheit scale, freezing point of water 0 30 to 10 50 20 68, boiling point of water 100 to 12. The ratio of 20 tenths on the Celsius scale is 2010 is equal to 2, whereas the ratio of equivalent data points on the Fahrenheit scale is 6850 is equal to 1.36. Incompatibility between the ratios. We can take another example of an interval scale as a time of the day. We have a 12-hour scale and 24-hour scale. 12-hour scale to PM 3 PM 4 PM 5 PM 6 PM 7 PM 8 PM 24-hour scale 14 15 16 17 18 19 20. On the 12-hour scale, the difference between 4 PM and 2 PM is 2 hours. Also on the 24-hour scale, the difference between 16 and 14 is 2 hours. However, the ratios are not equal. 4:2 is equal to 2 and 16:14 is equal to 1.14. The reason why the ratios are not meaningful in an interval scale is because of the absence of a natural or absolute zero. The zero on an interval scale is just another point and is arbitrary. The freezing point of water is fixed at 0 degrees centigrade. We have already noted in the original scale that the zero is boiling point of water. Similarly, midnight 12 AM is fixed at 0 hours. It is arbitrary too. PAGE 6 vertical bar 8. 2.4 ratio scale. The interval scale wherein the ratios are equal is called a ratio scale. Measurement of height, weight, distance, etc. are examples of a ratio scale. The other examples include sales, profits, costs, etc. Let's us take the measurement of distance. Meters, kilometers, 00, 1001, 2000 to 3003. The intervals between any two consecutive points on both the scales are the same. 3 kilometer, 2 kilometer is equal to 2 kilometer, 1 kilometer is equal to 1 kilometer. 2000 meters, 1999 meters is equal to 1999 meters, 1998 meters is equal to 1 MTR. At the same time, the ratios are also equal. However, the ratios are not equal. 3000 is equal to 1.5 and 32 is equal to 1.5. In the same way, the ratios of sales, profits and costs are also meaningful. In a ratio scale, the ratios are meaningful for there exists an absolute zero. In comparison, the interval scale will have an arbitrary zero. 3. Level of measurement and choice of statistical measures. When the data is on a ratio scale, we can compute all three measures of central tendency, mean, median and mode, and all measures of variance. However, in case of the data on nominal scale, we can use only one measure of central tendency, i.e. mode. The following table presents the summary of the choice of measures of central tendency and variance for different levels of measurement. Leave of measurement, choice of measures of central tendency, choice of measures of spread variance, nominal mode only, non-ordinal mode and median, interquartile range, IQR, interval mode, median and mean, IQR, range, variance and standard deviation ratio mode, median and mean IQR, range, variance and standard deviation. PAGE 7 vertical bar 8. What level of measurement is desirable? Where possible, it is always desirable to measure by the ratio scale, because the ratio scale data allows the application of many statistical tools on it. 4 different types of data. Univariate data is data that concerns only one variable. The data concerning the heights of a finance class of 30 students presented in the following table is an example of univariate data. Individual weight, kg, 175 to 71 382. 3078. Bivariate data is data concerning only two variables. Continuing with our earlier example, if we add the weight of each student along with his/her height, it will be a bivariate data. Individual weight, kg, height, CMAs, 175 172 to 71 169 382 174. 3078 176. Multivariate data is data concerning more than two variables. Individual weight, kgs, height, CMAs, marks in a exam, max 100, gender. One 75 170 to 80 male to 71 169 75 male 380 to 174 82 female. 3078 176 69 male. PAGE 8 vertical bar 8. Categorical data. The data measured on numerical or ordinal scale is generally referred to as categorical data. Categorical data is also referred to as nonparametric data. Numerical data. The data measured on interval or ratio scale is generally referred to as numerical data. The words numerical data, metric data, continuous data, parametric data are generally used interchangeably.